Hello again and welcome to my video on antibiotics and superbugs for the new AQA GCSE course. The things we're going to cover in this video are what are antibiotics and how exactly do they work, and what are superbugs, how do they develop, and most importantly, how can we go about stopping them. First of all, what are antibiotics? To get to the bottom of this question, you've got to look a little bit at cells and play a game of spot the difference. On the left you've got an animal cell. These have features like a nucleus and mitochondria showing they're a eukaryote or more developed cell type. On the right you've got the bacteria cells. These don't have a nucleus, they don't have mitochondria, but they do have a cell wall around the outside, which is a difference between the cells. What antibiotics basically do is they look for differences between bacteria cells and animal cells. They target those differences, and by doing that, they're able to kill the bacteria without being able to kill the human cells. When I say this, there are a couple of caveats. First of all, not all antibiotics actually kill the bacteria outright. You don't always need to actually cure illness. What they can do instead is just stop the bacteria already there from dividing, which means that there are never enough bacteria to cause an infection in the individual. I also have to say that antibiotics are only completely safe for human cells at the normal doses used in treatments. Sometimes people do get ill from antibiotics, either through rare allergic reactions, if they've got kidney failure, or if they take more than a recommended dose. So although antibiotics are usually very good, there's some situations where you might not want to use them on patients. Now to look a little bit at antibiotic resistance and what it actually looks like. First of all, so you can see what it looks like when you've got bacteria which aren't resistant. On the left hand plate, you can see the bacteria where there's a light white colour on the agar plate. What's completely normal on this one is around each of the antibiotic discs you have a clear area called a zone of inhibition. What this means is either the bacteria are killed in these zones, or they're not able to divide so they can't grow properly. That's what it should look like if the antibiotic is actually working. What can sometimes happen is bacteria can adapt, which means they're not able to be killed by the antibiotic, or it can't inhibit their division. What you can see on the right hand plate is you've now got some resistant antibiotics. Where they're growing right up to the edge of the antibiotic discs, so on those two there, it means that they're resistant. Now there's quite a few different superbugs, but the diva of the superbug world has definitely got to be MRSA. This bacteria really steals the limelight, and it's the one you hear about far more often than any others in relation to superbugs. I'll show you now why it's not quite so super. MRSA is a form of a normal skin bacteria, Staphylococcus aureus. This is present on a large proportion of the normal population, and it usually doesn't cause any issues. But in patients who are in hospital for a long time, or who have a weakened immune system, Staphylococcus aureus can sometimes cause blood poisoning, which has serious complications. The MRSA stands for methicillin-resistant Staphylococcus aureus. So Staphylococcus aureus is a bacteria species. Methicillin-resistant means that that strain of MRSA has evolved to not be killed by the antibiotic methicillin, meaning it's ineffective. So you may be wondering how this evolves in the first place. Well, like any process of evolution, it starts with variation within the population. So some bacteria are able to take slightly higher doses of antibiotic than others before being killed. This is completely normal, and it's just because there's a mixture of genes within the population. These differences only become a problem if something goes wrong. So the antibiotic is given someone with a cold or flu who doesn't actually need it because they don't treat viruses, or if the patient feels better and stops taking a course of antibiotics before the end, which means some of the bacteria can survive. What these things do is they select just the most tolerant bacteria to the antibiotic. These ones then survive and they pass the resistance genes onto the next generation. If this happens once or twice, it's not a huge problem, but over several generations, the resistance builds up and builds up until the antibiotic is completely ineffective against that strain of bacteria. So what can we actually do about this problem to stop the spread of MRSA and other superbugs and resistant bacteria? Well, the first thing that can happen is we can minimise or stop the inappropriate use of antibiotics. So that means stop giving them to people with colds and flu because it's not going to actually treat a virus, it only works on bacteria. Stop giving antibiotics to cattle when they're not even ill because it boosts meat yield. And as a patient, make sure that you always finish the full course of antibiotics, even if you start to feel better before you've taken all the tablets given to you. We can also make sure we practice good hygiene, which applies in hospitals but also in day-to-day life. One of the best ways to defend against bacteria is to actually wash regularly using soap. You don't even need antibacterial soap, just normal standard soap will kill the vast majority of bacteria, including resistant bacteria, on your hands and body. If you've got access to alcohol hand gels when you're visiting hospitals, that's even better. On the topic of hospitals, one more thing we can do to reduce the spread of superbugs is to make sure the hospitals are regularly cleaned. We can also use antimicrobial fittings, which are, instead of using standard door handles and taps and things like that, you could actually get one which contain metals which are able to kill bacteria, which means they can be kept more sterile and reduce the risk of contamination. Thank you very much for watching, and join us again next time.